There is an entire subfield of sociology dedicated to studying science as a social process, and it is called the sociology of science. The sociology of science sees science as a social institution and sees the construction of scientific knowledge as a collective activity, shaped not only by scientists themselves, but also by politics, institutions, the peer review process, funding, who gets funded, and other social factors. As Ben David and Sullivan explained way back in 1975, the sociology of science deals with the social conditions and effects of science and with the social structures and processes of scientific activity. Sociologists of science are interested in a lot of questions, including how did this particular tradition of modern science emerge and become institutionalized? How is science maintained and controlled? How is research organized? And what determines changes in scientific organization? And how are these changes related to research? A key figure in the rise of the study of science was Thomas Kuhn. Kuhn was an American physicist, historian, and philosopher of science, and he is well known for his seminal work called The Structure of Scientific Revolutions, which is a book that came out in 1962. In this book, Kuhn proposes an alternative way of understanding changes in science. When Kuhn was writing, the dominant view was that science was a cumulative, linear process in which individual scientists built on the work of the scholars who came before them. So science was seen as an accumulated body of knowledge. Findings were believed to be like a brick structure that kept on building. And this conception of science sees individual scientists as the brick layers. But Kuhn argued that science did not evolve in a linear, cumulative way. Rather than this slow and steady growth, Kuhn found that scientific changes happened as revolutions, and that these revolutions were structured by scientific communities. And we call this perception of science as structured and revolutionary the Kuhnian model of scientific change. What does Kuhn mean by this? Let's break it down. So everything that is produced by scientists is essentially filtered through the dominant scientific paradigm that governs ways of thinking in that particular time period. What is a paradigm? The scientific community agrees upon ways of seeing that will guide appropriate research questions and answers to those research questions. In other words, what counts as a reasonable puzzle that is worth pursuing. The scientific community also agrees upon the appropriate methodology for pursuing answers to those questions and acceptable instruments and procedures. For example, Newton developed laws of motion and gravitation, and these controlled physics for 200 years because of their explanatory and analytical supremacy. Then, slight inconsistencies in Newton's laws were discovered, which Einstein's theory of relativity explained perfectly. The end result was a paradigm shift from Newton's force of gravity in a flat, infinite universe to Einstein's curved space-time. Suddenly, the paradigm shifted, and entirely new perceptions of space and time and motion and gravity dominated. So if we think about Kuhn's model of scientific change in the context of the sociology of science, we can see how science is a community activity and how truth is dependent on the social context in which knowledge is produced. We can also see how paradigms influence our perception of reality. Paradigms are socially constructed frameworks within which a science operates. This means that individual scientists, professional bodies, specialized journals, funding, politics, and other institutions all shape the prevailing paradigm at any moment, and therefore shape the construction, progression, and production of scientific knowledge. I want to briefly highlight for you 3 key contributors to the sociology of science. We've already talked about Thomas Kuhn. Then we have Donna Haraway, who wrote Situated Knowledges, The Science Question in Feminism and the Privilege of Partial Perspective in 1985. And Haraway launched a feminist critique of science. She argued that even the most objective science is always partial because knowing always happens from a time and a place. For example, women's experiences of sexual violence were not researched until the 1980s because dominant male researchers did not ask questions about sexual violence. It took women becoming researchers and entering the academy for research questions on this topic to be asked, funded, and published. And lastly, I want to highlight for you Bruno Latour and his book Laboratory Life with Steve Woolgar in 1979. And a key argument of Latour is that facts are networked. So let's look at what this means. Latour's key idea is that facts are networked, meaning they stand or fall not on the strength of their inherent veracity, but on the strength of the institutions and practices that produce them and make them intelligible. If this network broke down, the facts would go with them. Latour is talking about the production of facts as social, a communal process, sort of like Kuhn, but he goes further to consider how the public is positioned or not positioned to interpret and believe the facts that are produced. Latour continues, facts remain robust only when they are supported by a common culture, by institutions that can be trusted, by a more or less decent public life, by more or less reliable media. It has become clear that whether or not a statement is believed depends far less on its veracity than on the conditions of its construction. That is, who is making it, to whom it's being addressed, and from which institutions it emerges and is made visible. So basically, Latour is saying that whether or not people believe a scientific claim is less about the rigor and authenticity of that claim and much more about the perception of where that claim is coming from and how it is presented to the public. And facts around emergencies and disasters are certainly networked. Think back to the COVID-19 pandemic, for example. Some groups of people were more or less likely to get the COVID vaccine. And this can be connected to the level of social trust that they have in mainstream media and in medical authorities, as well as concerns about pharmaceutical companies seeking profit. And these are all tied to the conditions of the construction of facts about vaccines and how COVID vaccines were presented to the public, who were the authorities doing this presenting, and how were these vaccines made visible. And lastly, within the sociology of science, we see science as a social institution. What is a social institution? Jonathan Turner explains it is a complex of positions, roles, norms, and values lodged in particular types of social structures and organizing relatively stable patterns of human activity, with the goal of addressing fundamental problems in producing life-sustaining resources, in reproducing individuals, and in sustaining viable societal structures within a given environment. So there's a lot to unpack with this definition. Let's begin by thinking of it this way. Imagine you're playing a game. In this game, there are certain rules, roles, and expectations that everyone follows to keep the game running smoothly. These rules tell you how to play, what's considered fair or unfair, and how to interact with other players. That's kind of like what a social institution is in society. It's like a set of rules and expectations that we all follow to keep society running smoothly. Now, in society, we have different areas where these rules and expectations apply. For example, think about school. Schooling is a social institution. It aims to pass on knowledge and socialize the next generation of people to be engaged citizens and obedient workers. And there are rules at school for when you have to be there, how you should behave in class, and what you need to do to pass your exams. But social institutions aren't just about schools or education. They're about other big things in society like families, governments, religions, and yes, even science. Each of these social institutions has its own set of rules, and expectations that help keep them running. Now let's look at that definition again, but in simpler terms. A complex of positions, roles, norms, and values. This just means that there are different parts and expectations within each social institution. For example, in a family, you have parents, children, grandparents, and each of them has their own roles and expectations. The definition goes on, organizing relatively stable patterns of human activity. This part is saying that social institutions help organize how we do things in society. They establish routines and ways of doing things that tend to stay the same over time, with respect to the fundamental problems in producing life-sustaining resources, in reproducing individuals, and in sustaining viable societal structures. This last part is about the big things that social institutions help with. They help make sure we have the things we need to survive, like food and shelter, and they help maintain how society functions. And the last part, within a given environment. This just means that social institutions operate within the context of the society and the environment that they are in. In a society like ours, certain social institutions like the government, the legal system, and the economy have been shaped by systems like imperialism and colonialism. And this means that they often reflect and perpetuate unequal power dynamics, discrimination, or oppression. And social institutions don't look the same over time necessarily or between societies. Now, let's talk about science as a social institution. Just like the institutions of education or the family, science has its own set of rules, roles, and values that shape how it operates. Scientists have specific roles, like researchers or lab technicians, and there are norms and values within the scientific community about things like objectivity, skepticism, and peer review. And as Kuhn told us, science isn't just about discovering facts. It's also deeply influenced by the social context in which it operates. And so this means that things like funding priorities, cultural biases, and power dynamics can all shape the kinds of questions scientists ask and the conclusions they draw. And this has been reflected in the role that science as an institution has played in enabling the construction of race and legitimizing institutional racism. For example, race came into existence as part of early Western scientific conceptions of race developed within the context of settler colonization and the Atlantic slave trade. One of these scientists included Linnaeus, who lived from 1707 to 1778. Linnaeus published 9 volumes on race in the mid-1700s, and he argued that there were just 4 groups of people, as we can see in this table on the right: Americanus, Europaeus, Asiaticus, and Africanus. And the way he organized these categories, for example, words like straight, white, muscular, stiff, lazy, framed non-white individuals as inherently and scientifically inferior to white people. And in doing so, science as an institution justified dispossession and slavery. Now, if we go back to our thrush reading about the Cascadia subduction zone and indigenous seismic knowledges, we can see that colonizers of Turtle Island often used so-called scientific ideas to argue that indigenous peoples were inferior or less advanced. And this framing justified taking indigenous land and resources. In this way, science as a social institution served the interests of those in power who wanted to expand their territories and exploit natural resources. Thrush and Ledwin remind us, quote, geological investigations of the northwest coast of North America went hand in hand with the dispossession of the region's indigenous peoples and the denigration, dismissal, and dismantling of their systems of knowledge. So science in this context was used as a tool of domination and oppression. It helped legitimize and authorize the violent settler colonial dispossession of Indigenous peoples.